Bitcoin has certain advantages over all competing forms of money. And scale is not one of them. Like, if you want scale, there are better solutions already out there. Setting capacity in terms of demand is the same saying as the capacity is infinite, because you will create infinite demand if the price is nothing.
Pieter Wuille, thank you so much for coming today.
Yeah, no problem.
I know that this is rare that you do podcast interviews, so I'm very excited that you're here. Fair enough?
Yeah.
Extra exciting for me. You've obviously been at the epicenter of Bitcoin development for 15 years now. Is that accurate?
Almost, yeah, I guess. Discovered Bitcoin in December 2010.
I think that's right.
So just over 15 years. So
I think you're coming up on your 15-year anniversary from your first commit in Bitcoin.
Okay, when was that?
I actually don't know. That's just what ChatGPT told me. I was going to ask you if you remember your first commitment.
Must be somewhere in the first half of 2011. I'd say maybe March, April.
Interesting.
I think in May is when I started being maintainer for Bitcoin. Well, at the time, just called Bitcoin, but what's now Bitcoin Core.
Well, I'm very excited to kind of talk about how you became maintainer and how you got into Bitcoin generally as a starting point. But before we go there, so you have, I think, maybe the second or third most commitments in Bitcoin ever, if I'm not mistaken, somewhere along those lines.
That's possible, but it's a bad metric.
Do you think so?
Yeah, because you can have many, like, you can do commits that change a typo somewhere,
nothing.
Or it could be a commit that rewrites a whole subsystem. And so, in fact, I think early on, this must have been, I don't know, 2013, 14 maybe, there was this service where people could tip and the funds would be distributed based on commit count.
Oh, wow.
And we had a couple of contributors who would like make a new feature, which was nice, and useful, but it would be like split up into tiny commits.
It's like DDoS. It's like
yeah. I mean, it's I forget the name, but like
they abused it.
And there's this term for how once you start rewarding people based on a metric, it ceases to become to be a useful metric. So.
I mean, that makes sense. Well, I will say, in addition to having however many number of commits that you have, I think that very few people will argue with me that the contributions you've made to Bitcoin may have been most impactful, legitimately, maybe since Satoshi himself. Possibly. I actually had a good mutual friend of ours, who I won't dox, but he described your work as having cleaned up the code that Satoshi originally wrote that, at the time, sort of functioned more like a science project, like kind of appeared more like a collegiate science project. And that
I think it's fair to say that the code base we inherited from Satoshi wasn't very modern. In some ways, it was very well written. There were very few bugs or problems or stuff like that, but just code architecture wise, I think it was, just give an example. The wallet code and the consensus validation code and part of the GUI were all in the same file.
Wow.
main.cpp. Of which I think one of my first contributions, certainly in the first year, was moving the wallet out of that. And
various other wallet-related changes. I mean, eventually HD wallets, seedphrases. I mean, you did quite a bit there that we'll speak about as well. How did you get into Bitcoin, though, just to kind of set the stage?
Sure. So at the time, I was doing my PhD. So this was the end of 2010.
At In Belgium.
In Belgium.
Which is an
University of
amazing crypto program, but you were not in the cryptography program.
Correct. I hadn't, for historical reasons, the cryptography research group was under the electrical engineering department and not computer science.
Interesting.
And I studied computer science, so I never had anything to do with all that.
Interesting. Were you interested in cryptography at all before you discovered Bitcoin?
I had a passing interest, but never really looked very deeply into things. So, and in where was I?
So you
right. This my research was about functional programming languages and constraint programming and programming language design. So I hung out in an IRC channel about the Haskell programming language, which had a BLA channel, Haskell BLA, where the same people were, but you were not allowed to talk about Haskell. And someone brought up Bitcoin there. And this was somewhere December 2010, and looked into it a bit, looked at the source code. Thought, this is cool. Just money, just on the internet, nothing else. I happened to have a GPU at the time that could mine a block per day or something.
That's a nice 50 Bitcoin a day.
Yes, very briefly, and no, I didn't keep them.
Many such cases.
But yes, I'm sure. And I started hanging out there, and I think then in a bit later, Hal Finney posted on Bitcoin Talk this challenge of here's a Bitcoin private key. I sent 5 Bitcoin to it, I think. Here's a private key. If you can take the funds, they're yours. And
so that was difficult to do back then.
Because Bitcoin Core, or Bitcoin as it was called, just didn't have an export or import feature for private keys.
Oh, interesting.
And
I think that may have been your first commit.
It was.
Okay.
It was.
Now I remember. Okay.
Yep. It's your research. Yeah, exactly. And so I think there were 3 people at the time that I know jumped on this challenge. One of them was Mike Hearn, who was already working on Bitcoin J. Momchil Georgiev, who was author of an Python OpenSSL GPU miner, and I. And I just tried to do it by adding an import feature to Bitcoin Core, which turned out to be much harder than I had anticipated. So I didn't win. But
so that means that you were making, just so that I'm getting this right, you went straight into working on code for Bitcoin Core as a way of fixing this problem, as a way of addressing. So you immediately got into code development right off the bat, pretty much.
Well, I think I knew and used the Bitcoin software for several months before ever looking at
for
the
mining.
Code. Yeah, and just sending to people and playing around with it and whatever. But so I had this patch for importing private keys, and I used a format that's now known as the wallet import format, WIF. But that's what I came up with there. But I hit this problem where internally in the Bitcoin Core wallet, it would track the spentness of transaction outputs in your wallet per transaction. So it would, if you'd have one transaction that pays you twice, which is possible, the receiver would only track whether both of them are spent or neither are them spent.
So they became like conjoined twins.
Yeah, which is not a bad idea for privacy reasons, but it does mean you could hit this weird edge case where when I wanted to introduce importing keys, because say I send you coins and change goes back to myself, and now somehow you import my private key, and then you send your coins further, they're gone, and now you import my private key. So now you have one output, the one that was sent to me originally, which is still available, and the one that was sent to you originally, which is gone. And so the wallet couldn't represent this state. So I sent a message to Gavin Andersen, who had taken over recently at that time as lead maintainer of Bitcoin software. Satoshi was already gone.
Satoshi gave the keys to Andersen, right? I mean, that was like the order of events.
Yeah. I don't know exactly when that was. Probably end of 2010 somewhere. Probably before I got involved. But so I sent an email to Gavin like, hey, there's this edge case that I don't know how to deal with, and I had some ideas about how to fix it. Gavin was like, that really sounds like an edge case. Maybe you can work around it this way. But said, I've also forwarded your email to Satoshi. And
your email?
Yeah, mine.
Okay.
And then briefly after that, I don't know when, I got an email back from Gavin with Satoshi's response saying, yeah, the way the code does it is dumb. Here's a patch to fix it. That patch didn't work.
Okay.
But that became, I think, my first PR.
That's how you really got involved deeply.
Yeah.
How many people, I mean, was it just Andersen at the time who was working on the code base? I mean, how many people were working on the code base back then?
There were a couple people, I think Macrello was around already. He was 17
or something?
Something like that, I think. I think Luke Dash Jr. was around. Peter Todd, I think, was around, but maybe not so much involved in the code base. I mean, the other maintainers were Jeff Garzik. I think Nils was still around.
Maybe 10, 20 people were actively contributing to the code base at that time?
It was certainly very different. I mean, these things change so gradually, but if you do look back at what pull requests look like at the time, it's like someone's opening it, sounds like a good idea, merged. There were no tests.
Wow.
The Bitcoin code base had no test, periods.
Whoa. No one really took it seriously, I assume. I mean, everyone was just like monopoly money at that point.
I guess, but yeah.
The stakes were not quite what they are today.
Absolutely. And it is pretty remarkable, I think, how bug-free the code was despite that fact.
Props to Satoshi.
Yeah. I mean, he or she or them clearly had a very good idea of how everything worked together, and but yeah, so and I think like a month later in May or so, Gavin was like, hey, I see you've been actively contributing, I assume you want to help out, I've given you access to merge changes.
Oh wow, were you
he didn't even ask me.
Really? He just gave you, just like, you're a maintainer now.
Yeah.
What was your response to that?
Okay.
Whatever. No big deal. Were you the second maintainer then after Andersen? I mean, was it Andersen and you?
No, because there was Jeff Garzik was also a maintainer at the time, and
okay.
I think there were others, but maybe Nil Schneider.
You were maybe third or fourth.
Yeah, there's a list online somewhere of, but yeah.
Interesting. Okay, so we've kind of gotten a little bit of a sense of what Bitcoin core development was like back then. When did you start kind of working on some of the big juicy problems? Like, okay, we could probably use seed phrases, and I'm curious even how that idea came to be. And
Bitcoin core doesn't support seed phrases and never has.
Oh, it doesn't?
No.
Oh, it does. Is it? So it's just the HD wallets and then the seed phrase. Okay. So tell me about that.
So that was BIP32. I think that was around 2012 that I started working on that. And this was based largely on an idea by Greg Maxwell, who I interacted with a lot over time, became a good friend, and we worked on many things together afterwards. But it
was his idea.
It was
the concept.
Like many of the things we'll talk about are his ideas originally.
Interesting.
So he made this post on Bitcoin Talk about homomorphic key derivation, where you'd have the ability to sort of have a master key from which you can derive multiple child keys in a private way. Someone who sees the child keys can't correlate them that they all came from the same master key, but it had a special property that if you had a master public key, you could derive the child public keys from it. So this allows you to create like this master key, but neuter it in such a way that you can still receive without having the ability to spend. And that's the basis for watch-only wallets today, right? Where you can have software that can watch all incoming payments and all outgoing and everything, but it doesn't have any private key material, so it's unable to.
Prior to that, this was just like a massive privacy problem, mostly, or was it like just an address management issue? Like, what was the problem that you were solving with this?
Backups. So prior to this, and even a long time after, because I think it took a couple of years before we got BIP32 support in Bitcoin Core, but anytime you wanted to generate a new address, there would just be a new random key generated, which means that you now have a problem because every time you generate a new key, you need a new backup.
Imagine like writing down your seed phrase for every single spend, practically, if you want to be super private with
every receive,
right,
and every spend,
spend,
both, because change outputs come back
exactly.
And the way the Satoshi software dealt with that was it had a look-ahead buffer of 100 keys that was later increased to 1,000 of future addresses with corresponding private keys to use. And with that, you only need a backup every 100 spends, because you already have the keys that you will be assigning in the future. But with BIP32, HD wallets, which was kind of a joke.
How much did Gregory Maxwell contribute to the code? Was it like his idea and then you actuated it? Or like, what was your relationship with him like on these big ideas? What were sort of the roles between you?
It was more the ideas that came from him. I think most of implementation work in these things was my... I think BIP32 also had a number of things that were inspired by Armory Wallet, which was another wallet node software at the time, which used this idea of homomorphic key derivation first. And I think they had internally that scheme used something called a chain code, which is now the name
reference point.
Yeah, and also the name of the company I work for. But so there were a number of ideas that sort of put together, wrote up, and then implemented. But BIP32, I think, was pretty interesting in that it was designed as a specification and published, and then many people implemented it long before my implementation made it anywhere.
How many implementations were there at the time?
Well, we had...
I mean, were there more than there are now commonly used?
It's a good question. There was certainly Bitcoin Wallet for Android that didn't use BIP32. There was Electrum, I think, already, which may not have used it in the beginning, but then switched to it maybe. There was Armory. There was Multibit.
Many of these have gone by the wayside.
Yeah, Armory is gone. Multibit is gone. Bitcoin Wallet for Android, I think, still exists. Exists. Don't know its status. I think that there was sort of a bigger explosion of wallet software a few years later. Maybe 2014, 2015, there were many more.
Were seed phrases... Seed phrases still do have a BIP, though, right?
Or BIP 39.
That is BIP 39. Okay, so it came slightly after 32.
Yeah.
And was that also Gregory's idea?
No.
Oh, that was you?
No.
Oh, whose idea was that?
I think this is the Trezor people.
Oh.
Pavel Rusnak or Stick.
Interesting. Also pretty useful. Kind of fundamentally changed, I think, how people interact with Bitcoin. So I like when that happens outside of the context of some dramatic consensus change. Okay, so another kind of early contribution of yours that I have a feeling probably was your own idea was libsecp 256.
It was, yeah. I think...
It feels like you. It feels like it has your name on it.
So libsecp started as a experimentation thing because, again, Hal Finney had posted on Bitcoin Talk about a particular optimization that was applicable to this elliptic curve that Satoshi had chosen to use for Bitcoin, the SegP 256K1 elliptic curve.
And ostensibly he chose that curve because there was an existing library and it was kind of out of the box and easy to use. I mean, why did he use that particular elliptic curve?
We don't know. I think maybe Mike Hearn asked him at some point and got sort of an answer like, I just picked something.
It was easy. It was on an OpenSSL.
It was in OpenSSL. OpenSSL was easy to use, to link to.
Maybe Satoshi was smart enough not to implement his own cryptography.
Perhaps. Unlike others.
We'll get there.
But OpenSSL, offered like a selection of elliptic curves to use, and it turned out that Satoshi picked basically one that no one else used. It was standardized by some standardization body, the SECG, I think, Standards for Elliptic Efficient Cryptography Group or something.
Okay.
But other than that, it was basically unused, but it was specifically selected to have this property of enabling a particular optimization, an efficiently computable endomorphism that made things 20, 30, 40% faster.
Okay.
But it comes with trade-offs too. It makes things a bit faster for attackers too. It imposes some structure on the curve. I think at the time people shied away from it specifically for that reason, because it had some moderate advantages, but it wasn't entirely clear if they would stand up, There
were maybe some vulnerabilities as well.
Yep. That weren't known. But somehow Satoshi picked that one, and to this day, Bitcoin relies almost exclusively on this elliptic curve for protecting funds and many other things. And so Hal posted about this fact that, actually this curve was specifically designed to enable this optimization, the GLV endomorphism, or efficiently computable endomorphism, but OpenSSL doesn't implement it. And he had taken a shot at, can I
take advantage of this?
Of that, and it looks like maybe can speed things up a bit. And so I briefly had the idea of writing a specific module inside OpenSSL for the SegB curve, optimized for that curve that would take advantage of that. I was working at Google at the time, and I considered Google has or used to have this thing called 20% projects, where engineers are allowed to spend 20% of their time basically on a hobby project.
On research of some kind, I assume.
Yeah. Many very interesting projects came out of it. I think Gmail.
Smart. Good for Google.
I don't know if they still do it, but many big things came out of that at the time. But I don't know. I think I got a bit of pushback of like, yeah, you're allowed to do this, but your other work will suffer, blah blah blah.
From Google.
Yeah,
Google was concerned about all the time you were spending on this internet money.
Possibly, but more not working on the other things. But
sure,
I did meet with one of the regular OpenSSL contributors who happened to work in the same building as I did, Emilia Casper.
Convenient
to discuss this. In the end, I looked into the code, and I wasn't very happy with the OpenSSL code, which was a big and old code base that had been inherited, and no shade on the people maintaining it. It was just a big old project but OpenSSL has been known for having vulnerabilities and
I think have like one maintainer. I mean, there's no real incentive to maintain it well. I mean,
I think around that time is maybe when there was a series of serious vulnerabilities discovered in OpenSSL, and it sort of got more attention. And I think in the few years that followed, it did get a bigger team and get some funding, and they did clean up a lot. And
after this time,
I think it was more a bit later. I think yes.
But so you were underwhelmed in the moment.
Yes. And so instead I just let me start writing a hobby project where I can do what I want.
Casual, implement my own ECDSA cryptography project.
Right. And don't can do everything the way I want. And more importantly, don't need to care about anything but ECDSA and the SegB curve. It would be very
specific.
Yeah, right.
Dan Benet said on a podcast that I listened to recently that no one should ever implement their own cryptography. and that this is the most risky, dangerous thing to do in the world. But you as a layman, ostensibly, just went for it. And now it supports Bitcoin. Was that intimidating? I mean, what were your thoughts going in? Did you take on those risks knowingly?
When I started it was certainly not intended. It's not like the plan was from the beginning to have Bitcoin switch to that. That would have been ludicrous to think. I think at the time.
Very bold of you.
I mean, it was really just a hobby project to see this optimization seems like a really cool mathematical trick. I want to see how much it actually gains. Ironically, for patent reasons, we actually didn't enable it until a few years ago.
Interesting. This was one of the other reasons that I heard Satoshi may have used ECDSA or picked that particular curve was because of patents on Schnorr. Does that sound right?
I think that I don't know. I think it's unlikely that the reason, because more indirectly, I think due to these patents on Schnorr, nobody worked on standardizing such schemes for a long time.
Right.
And as a result, they weren't available in OpenSSL.
Right.
And but there is now, and even at the time, ED 25519 existed, which is now a very popular digital signature scheme, which is effectively Schnorr. under the hood.
So now it's available a little bit more widely.
Yeah, but
so you went for it. You implemented your own ECDSA.
And I got some contributions from Greg Maxwell, who contributed a lot to the library, and Peter Detman, who is maintainer of a Java cryptography library called Bouncy Castle.
Okay.
And Peter Detman would just come up with these novel optimizations, like, I don't know, just novel algebraic tricks, and like, hey, here's a PR that makes things 10% faster, 5% faster.
Just crypto creative genius.
Yeah. And I think it fair to say that a very substantial portion of the code in libsecp, or at least of the low-level algorithms, are either implemented by him or have optimizations based on ideas of his.
So you had some help.
Yeah. And I think at some point, because as far as I know, libsecp had never had an exploitable vulnerability ever. So I think we had a good track record and good test coverage. Another thing that Greg Maxwell worked on, he would do these mutation testing, where he would try to introduce bugs into the code and see if the existing tests catch it, and then try to find tests specifically to cover all the possible bugs he would come up with, which I think is a really good technique for gauging how well your tests work. Because of course the point of your tests is increasing your confidence that the code is correct. But if your tests, if there's never a bug your tests catch, are you testing for the wrong things? Are you testing for the right things? So that was.
So there was some substantial review happening. How long were you working on this cryptography before actually implementing it, like, live on Bitcoin? Like, how long was this process of hobby project to, okay, now we're using this to secure real money?
So the first step, there was an intermediary step where we switched Bitcoin Core to using libsecp, but just for signing in the wallet code, because it was constant time, and it actually had advantages in that regards over OpenSSL. But not yet using it for validation. That stayed on when was that? Maybe 0.10 that we added it in the wallet. 0.12, or was it 0.8? I forget. But this must have been 2014, 2015.
Oh, so there was some time that lapsed. This was sounds like a multi-year process.
Yeah.
To fully integrate
I think around
this.
that time we were especially heavily working on just improving the libsecp code. But interestingly, I think this was a pretty interesting story. So in 2014, I was looking into, what one of the concerns we had, because as Bitcoin's consensus rules are not standardized, they're not defined by a body that people bless into being the real Bitcoin. It is whatever, code people run that is enforced on the network. So we have the code is law kind of principle. So that meant that if there were somehow bugs in OpenSSL, those would inadvertently, but still actually be part of Bitcoin's consensus rules. And this was the biggest concern for, switching it out for libsecp, which the main reason why we, at that point, started talking about using it in Bitcoin Core for validation is libsecp was something like 6 times faster.
And OpenSSL, what I'm hearing, was a dependency and arguably a central point of failure.
Yeah, it is a big surface because it's a big library that does many things, and
you only need this one little piece of it to work perfectly in Bitcoin, right? I mean, so it kind of made sense.
But in fact, it doesn't need to work perfectly. It needs to work exactly as OpenSSL does. Right? The goal wasn't to implement ECDSA for SegP 256K1 perfectly. The goal was do exactly the same thing as OpenSSL does, which we believe to be ECDSA for this curve.
Right.
Who knows?
Right.
Turns out there was around this time, I think I discovered in the function for computing a square of a number in OpenSSL, there was a bug, which magically somehow by good chance, and this was actually discovered because we had tests in libsecp that compared the outcome of operations with OpenSSL, and just by running it for a long time and testing many random cases, I had this, what the hell, I'm computing the square of a number wrong? No, it's OpenSSL that is wrong.
Oh, no.
It turns out that this didn't impact anything. Somehow it was not actually used in any of the code paths that mattered for validation. But
Bitcoin shouldn't be dependent on OpenSSL. This is sketchy, basically. It's a problem to have this dependency, ultimately, is the bottom line.
And it turned out to be much worse. So
much worse than the risks involved with just implementing your own ECDSA library.
Eventually,
in the end, that's where you got.
But
yeah.
I think this must have been maybe September 2014 that I started looking seriously in the OpenSSL code, because we were considering maybe at some point we want to switch validation to it. It must mean we need to implement exactly the same thing. And it turns out that there was this problem where, the ECDSA is specified well at a mathematical level. There are these numbers and they represent points on a curve, and you do these operations with it, and then a signature consists of 2 numbers. But in addition, there are, of course, rules that describe how these numbers are stored as bytes, that they're encoding on disk on the wire. And there are a number of standards for that. One of them is the DER standard. And OpenSSL thus has this code for reading and converting from and to between the mathematical form and the serialized form in DER. And looking at that code, I saw a problem, which was... So DER is the more specific version, but the standard allows you to basically be looser and allow more other encodings on inputs. And so the D stands for distinguished, which is the one version you should use, but there are many allowed encodings. And so OpenSSL supported many things that were not allowed by DER, which was fine. But what subset it supported was rather arbitrary. And short stories short, the set of allowed encodings that OpenSSL supported differed between 32-bit platforms and 64-bit platforms, which means that in theory, someone could come up with a specially crafted signature that would be valid on a 64-bit machine and invalid on a 32-bit machine. Not because the signature itself in the mathematical sense was invalid, but because the encoding was not supported.
So this is a functional bug, essentially. I mean, this does not work for Bitcoin.
It does not. Like, unlike many other cryptographic applications, Bitcoin doesn't just need the property that attackers cannot forge a signature. This is not a forgery. This is something that's, a user who has the private key creates a valid signature, but encodes it in a weird way. And so we need not just agreement on what signatures are valid, also which ones are invalid.
Correct. Makes sense.
And OpenSSL was never designed for this purpose.
This makes total sense. So when did we officially get off of the OpenSSL dependency?
So, I was sitting on this bug that I knew, which was a consensus bug.
You were like,
Bitcoin.
This has got to stop right now, basically. This is the moment that we're getting off of it.
Yes, but this became the more important problem to fix. Like, this could literally fork Bitcoin.
It's urgent.
And so BIP66 I wrote then, which was a narrow down version of BIP62, which was an anti-malleability proposal that had been working, that came out of sort of the drama with Mongox at the time, which turned out to be unrelated and whatever we know now. But whatever, BIP62 was proposed to deal with malleability, but it wasn't really going anywhere. And then it was we'd like to have faster signature validation, and we'd like to fix this consensus bug. And it being a consensus bug, like, the fix isn't a software change. We needed a consensus change in Bitcoin to outlaw those weird things that OpenSSL supported.
Wow. Yeah.
And so BIP66 was just gave specific rules on how signatures needed to be encoded exactly.
Consensus changes in general were more common back then, though. I mean, consensus
changes certainly a bit more frequent, but there were
still not super common.
Yeah.
Okay, fair enough.
I mean,
but you could have multiples in a year back then.
That was very rare.
Okay.
Maybe we had, I think maybe both BIP 30 and 34 were in in BIP 16. I think 2012 may have had more than one, but
wow. Okay. Okay.
Yeah, but
this was like 2014-ish we're talking about?
2015. 2015 is when BIP66 activated. And so it was sort of written under a pretense of enabling libsecp, because we couldn't move to this other library that potentially worked slightly different from OpenSSL without
a reason.
without encoding exactly what the rules were going to be and enforcing those rules. But the non and later disclosed reason was also, not only do we want to formalize the rules, we in fact know OpenSSL.
We need it.
Doesn't implement them correctly.
Right.
Or not for our purpose.
This is a problem that we need to fix now, rather than just a nice to have. It became a need to have.
Yeah.
This was around the same time as the block size wars-ish. This was like when the scaling conversation was kind of picking up.
Yep.
Moving right along. So, like, what was your take on that time period? Like, how would you describe that time period from your point of view as Bitcoin maintainer?
Not fun.
Not fun. How did I know? But yeah, I mean, just sort of generally, like, how did that, can you just tell like a tiny bit about how that all sort of picked up from your perspective, how that all kind of grew and started and what that was like, that sort of tidal wave that came over everyone?
I'd rather not.
Okay. Fair. Well, let me ask you this then. So you did, I remember, I mean, I know that you did your utmost best to be as apolitical as possible during that process. And you're sort of famous for, let's just build solutions. Let's just, write code, try to fix things with technical solutions, not infight. This was sort of your posture as I understand it. And you had a couple of proposals during that time that you put out to attempt to address this issue in a moderate way, I would say. Would you say that was your goal, moderation, some sort of moderate middle ground? We have a couple proposals that you put forth that I think sort of fit that description,
that
relatively speaking. That's right. What was BIP 103? This was your first proposal to kind of solve the scaling problem. No?
For getting into it, I think the phrasing of calling it a scaling problem, I think at the time there was this big difference in viewpoints, whether the scale should follow demand or whether scale should follow technical evolution. Because obviously, as technology improves, there is no reason why scale can't grow at the same time. But I think for many people at the time, there was a belief that not only should it grow because of that, but the reason for wanting growth is because people want to create more transactions. And I think, this was the whole block size war was about. Ultimately, is this. My viewpoint at the time is that is not a justification, because we're trying to build a system that has properties that decentralization, privacy, whatever. Bitcoin has certain advantages over all competing forms of money, and scale is not one of them. If you want scale, there are better solutions already out there. So to stick to the stay good at the things it's good at, there was a common argument at the time, if blocks are full, that's a problem. No, blocks need to be full. If blocks are if they're not, that means we have more capacity than
lost money for miners.
Setting capacity in terms of demand is the same saying as the capacity is infinite, because you will create infinite demand if the price is nothing. And so from that grew the BIP 103 idea, which just rejected the notion of we need a big bump now because there's too much demand. Categorically rejected the idea that that is a reason. We should increase the scale if we can, not because we need to.
And so BIP 103, we're just going to keep it purely technical right now. What was BIP 103 really just functionally proposing? Because I doubt everyone knows this.
7% increase per year.
7% increase in block size per year was the proposal of BIP 103. At that time, how was that proposal received?
Not well.
No.
I think I think at the time the polarization already resulted in the group that felt more capacity was needed because capacity needs to follow demand, says this is way too little. And I'd agree with them because I rejected that notion. And I think to those with a more modern stance, is this worth the risk of doing a hard fork for if it's only doing this?
And at that time, hard fork risk was more substantive than maybe it is now, or is that fair to say?
No, I think it's just a philosophical,
just generally
question. Will it split the currency in two or not?
Or not?
Will everyone follow? Yeah,
or not?
And maybe perception around this has changed now that we've actually seen, groups split off. But yeah, this was I don't know. I think at the time the proposal was just me feeling I was in the middle of it all. I needed to do something, and it was something.
You did eventually do something that was, I assume, received better because we have it now, which is SegWit.
Yeah.
How did the idea for SegWit come about?
So at Blockstream at the time, we were working on a product called Elements, which later turned into Liquid. That's still around. And in Elements, we experimented with a number of, big changes that we could make because it was just a new chain. It was based on the Bitcoin code base, but, we could do all the stuff. Like we could just, if we wanted to redesign Bitcoin from scratch, how would we do it? Make changes that would be impossible to make or just fundamentally different and whatever. And one of them was SegWit. I'm sure it was inspired by an idea by Greg.
A Greg Maxwell classic idea.
And at the time, just this was a malleability solution problem, because the idea was like we'd have the transaction and the TXID, the transaction identifier that commits to the effect of the transaction, but then the signatures would be separate so that when the signatures change, the identifier of the transaction doesn't change. So we just, the witness being a name for mathematical term for basically the proof that shows the transaction is valid. Those are the signatures. We move them out. So we create them.
And that was the original intent of SegWit. There was no, at the time when you were first ideating on this, there was no thought, and also we'll get more data space out of this.
So this was not combined with what's now known as a SegWit discount that didn't exist. It was not envisioned as a soft fork. It was just elements work this way and Bitcoin didn't. And it was absolutely not envisioned as something that we could add to Bitcoin.
So when did that change? I mean, when did this evolve into the SegWit soft fork that we now know and love?
I think this was October, November 2015, maybe, where Greg and I were talking at some event about, and I think it was just the realization that we could add a witness discount, which would because since this witness data, if it's done as a soft fork, is data that old nodes don't see, we can basically put arbitrary rules on how much size we assign to it, because old nodes see it as size 0. So anything,
so it's backwards compatible.
Yep. And we could give it weight 0, but that would obviously enable infinite data storage. And so we picked this trade-off between, how costly is the data, because the witness data is literally cheaper to the network in many ways than the other data, because it never enters the UTXO set.
Makes sense.
It's just there needed at validation time, and then you don't need it anymore. You still store it, of course.
That's why you can prune it. That's why
you could, but it's just not data that ever like, it's data you need to see once. You store it, but storage is cheap. So there are, of course, bandwidth costs to it and storage costs, but much less processing database I/O costs. So from that reason, let's give it a factor 4.
Was that somewhat arbitrary, or were there like
It's somewhat arbitrary.
Okay.
It's just like draw a curve of what capacity gains do you get from that, and so this allowed us to do a capacity increase at some extent, a moderate one.
Did that at the time
as a soft fork, at the same time also fix the malleability issues, which was something that Lightning very much needed at the time, and use it to make a number of other improvements at the same time too.
So was the energy of that conversation like, oh, we can kind of throw a bone to all these people who want this block size increase whilst we also accomplish these other things? That was sort of the energy. Which I think is pretty diplomatic of you, relatively speaking. I mean, you know, as far as one can be in this situation.
So, but
how?
Go ahead.
Oh, I was going to say, how was that, received? So once you put this soft fork proposal for SegWit out, what happens then? How was the process through activation?
I think that went pretty well. Like, I presented about it in Hong Kong in December 2015, and this was the first time we talked about it publicly. So it was like both an announcement and a talk. And from many people, I was like, wow, like
nailed it.
And at least within the active developer community, not universally, of course, but it seemed to get many people excited. And so that was December 2015, and SegWit activated after a whole bunch of activation drama too, which involved BIP 148, BIP 91. There were these meta proposals, because it had an activation threshold of 95%, and it wasn't clear if this was going to be reached.
Was there a reason why activating this was so much more difficult? I mean, you hear a lot about sort of activation challenges with SegWit and Taproot, but again, you'd previously had these consensus changes that seemed to just happen, no problem.
I think just the attention that the political drama of the block size war brought made it harder.
Were miners more involved? I mean, was there this feeling in the past that miners just kind of upgrade whatever, and then now they're sort of taking more of a stance or something? I mean, was that the issue?
Definitely. And also there was just, due to the public dispute about it, it was a much more legitimate political opinion to say, I don't want this.
Right.
And that's where the idea of a user-activated soft fork, because the very early soft forks were not miner-activated, right? The Satoshi ones were just like this,
they just happened.
It just happened. It didn't have activation at all. It's just run the new software. It comes with new rules.
Do you see this as, a healthy development? I mean, obviously there's a lot of challenges that come with managing and navigating these sort of, political environments. But I mean, do you functionally see it as healthy that now there's debate and the community is getting involved in governance in a real way?
Yeah, I think it's better. I mean, these are the sort of changes that should be consciously made by the ecosystem. I wouldn't say I like the...
It's not fun.
But there's also... Just like... It does go into... how do you call this? Getting involved in technical conversations where
with folks who maybe are not as technical.
Yeah, but this is hard, right? Like I really don't know what the answer is here. It's unambiguously a good thing that the Bitcoin ecosystem consciously chooses what rules it wants. I don't like the populism and drama and polarization and whatever that this seems to involve, but maybe it's part of it. I don't know.
I am hearing a little bit also, and I don't think that this is just an issue with Bitcoin. I think that this is a challenge in all democracy, for lack of a better term, that it is, you're sort of constantly weighing this challenge of we want as many people who are affected by these changes to participate in the conversation. And also, you kind of have a structural education problem at the same time. It's very difficult to kind of get everyone all the information that they might need to make an informed decision. Is that maybe...
Yeah,
am I directionally correct there?
Yeah. But just I do think it's important to point out, but Bitcoin is not a democracy. Like the consensus rules are enforced by 100% of the people, not a majority. The only thing where a majority matters is in mining, where it is a majority hash rate that decides what the active chain is. But the rules of what blocks and transactions are valid is Bitcoin's consensus rules, and I think its most important feature is these are rules that are so objectively enforceable that you don't have to have there doesn't need to be debate about it. It's just these are the rules that everyone chooses. Like the Bitcoin ecosystem consists of all the people who agree with its rules.
Do you think everyone feels that way? Do you think everyone feels empowered in that way?
I wouldn't say empowered.
I imagine some people feel like they okay, I have to live with this choice made by the majority, whatever that means, even though I don't want to. Because what are my other choices? Go to some other altcoin chain,
Yeah, I mean, I philosophically, I very much agree with this notion of everyone chooses their own rules and there are trade-offs involved, because obviously you don't want to pick rules that only you choose, because now you have a currency of one user and what's the
you don't actually have a social network anymore.
Yeah, but at the same time, it is entirely voluntary. You don't have to use Bitcoin. If you don't like its rules, you can use something else. And I think it is, in a way, very healthy that you have that choice.
Yeah, and some people have exercised that choice by forking off.
Right.
Yeah. So, how soon after SegWit did you start working on Taproot?
So I did look up the timeline for that before coming here.
Oh, good. You did homework too.
So it was in January 2018 that the idea for Taproot.
The idea.
A
Greg Maxwell idea?
Of course.
Of course.
we were having lunch in our favorite breakfast, maybe, I don't know, a breakfast place in Los Altos in California, where we'd often go with Andrew Poelstra, Greg Maxwell, and I. And while I was briefly in the restroom, they came up with Taproot.
I missed it, but they filled you in pretty quickly.
Yeah. This idea of we could create an output that looks like just a pay to pub key, and it can be used for both a key or a script if you want to do something more complicated, but you don't have to reveal that there was a script involved in the first place, as long as you always use the key path. And we make that one by far the cheapest one, so we incentivize everyone to use the one thing that's indistinguishable from everything else.
That's a very nice summary of at least some large chunk of what the Taproot activation did. It's funny because Shore's Provost, I was listening to a podcast of his, and he said, compared to SegWit, Taproot is simple. But that I'm not sure is how most people view it.
It is.
You think so?
I agree with that.
You agree with him?
I think in a big, like, SegWit was a much more fundamental change. It introduced like a new area within a transaction that didn't exist before, the witness. It changed the peer-to-peer protocol to make use of that. It introduced the notion of weight. It introduced script versioning. It introduced WTXIDs being separate from TXIDs, and like
it was a huge, juicy, big, full change with major implications for how Bitcoin works.
It touched quite a bit of things, like it was like an enormous amount of code or anything, but SegWit did touch a whole lot of stuff.
It's conceptually a little bit more intuitive, though. Like when you talk to laymen, kind of industry level laymen, right? People who are following this, they kind of get SegWit. You can kind of grok it pretty easily. Yeah. I've had conversations with, developers, like pretty, sophisticated developers in Bitcoin, and I'm saying, what's Taproot? And they have trouble communicating it as clearly as you just did.
But like, I think it's fair to say that Taproot was a minor successor to SegWit, to like, make use of the script versioning system that SegWit introduced to improve on a few more things that SegWit didn't. And the Taproot idea itself is the main thrust there, but it also introduced a masked tree of scripts, so you could have multiple scripts at the same time. It made some changes to how the SIG hashing works to fix some minor denial of service issues. Made a few more changes that helped with like hardware wallets, so they wouldn't need to see all the details of a full transaction and could just look at parts at a time. And
it introduced Schnorr.
Absolutely, yes.
That's a biggie,
right? But in terms, like Taproot in that sense is a much more localized, contained change. It's just improve the script system with, to be fair, a big change to the script system, but it's just that. Nothing else is touched. It doesn't change transaction serialization. The peer-to-peer protocol doesn't change weights. It doesn't change like all these things that SegWit affected. Taproot just made use of them to, let's do a somewhat better scripting system.
Are effectively, so you're creating a new output type. You're making changes to script, right? Creating new script, essentially. That would be fair to classify with the Taproot.
Taproot, in terms of opcodes, it didn't really change much. It swapped out ECDSA for Schnorr.
Okay.
Enabled batch validation, which needed a few changes, made a few tiny tweaks. But so what Taproot does is, first of all, it adds a Taproot construction, which means every output now basically becomes either a key or a script. And if you just want to spend with a key, it's just a signature. There is no script involved whatsoever. You just have an output to a key, you reveal a signature with that key, you're good. Or you reveal, actually, this output commits to a tree of scripts, and I reveal one script of them, and here are the inputs for it.
Was the primary benefit that you guys were going for privacy?
Yes.
Okay.
Yes. But along with it came like, okay, this is a big change to the scripting system. What else are we going to put in? Because there were tons of proposals at the time for other things we could do. Cross-input signature aggregation was considered, new SIG hash modes, whatever. And we chose not to add those just because it was already a big blob of things that just There were voices at the time that argued for splitting Taproot up into more granular pieces. We didn't do that because there were some significant synergies between them. Like you wouldn't get all the benefits if you do them separately. But many other things that didn't go in. And so I think Taproot deliberately didn't change script functionality. Like it just kept all the functionality, but like fix a few minor things and this big thing of, well, you don't always need to reveal the full script anymore.
Do you consider the introduction of Schnorr not chunky and weighty and meaningful in and of itself? I mean, that
Sure.
feels like a pretty substantive change. That was the first time there was sort of an introduction of a new cryptography into Bitcoin?
But the same curve still.
Sure.
Which was also deliberate.
But
because,
still.
Yeah, that's fair. That
I mean, it's not. Yeah.
But I don't know, it's like a difference between how conceptually big and how,
like just practically.
Yeah, how many things does it touch? Like the Schnorr change is arguably the smallest change of them all. Is just replace opcodes from a check ECDSA to a check Schnorr.
But it needed to be handled very carefully, again, because you go back to this sort of challenge of what it means to be implementing cryptography, which is difficult.
Sure. But
you were old hat at that by that point. You're like, we got this, no big deal.
I think we knew how to do things like that at that time. I wouldn't... That was not the challenging part, I think. That there were... The changes in like sig hashing, I think, were more involved and benefited a lot more from having lots of eyes on them.
Out of curiosity, and this is kind of a small side note question, but I have to ask, why did you choose not to hash the public key and the key path spend for Taproot? Because historically, most of wallet addresses or output types do have hash public keys. Was there a reason why you decided not to do that with Taproot addresses?
Yes.
I'd love to hear it.
It's pointless.
So, like, hash public keys is just a meme.
Public key should be public. That's what the cryptography is designed for. And adding a hash there, it just undoes some of the benefits. Like the point of Taproot was introducing this new output type that is the most efficient way of using Bitcoin, and it beats everything else. And by doing that, it incentivizes everyone to use the key path. I'm just talking about the key path.
So there's an efficiency issue.
It's an incentive thing. Like if there was an additional hash there, it just wouldn't have that benefit. It wouldn't be better than everything else.
Do you think that all of current addresses, I mean, SegWit addresses have hash public keys? Do you wish that they didn't? I mean, would you prefer that there were no hash public keys in any output types?
I think if I designed Bitcoin today, there wouldn't be.
Okay, interesting. Yeah. And you would say for the same reasons?
Yeah.
Noted. All right, guys, I want to take a quick break to thank you for watching and remind you to click the follow button on my profile if you want more Bitcoin technical deep dives like this. I also want to give a shout out to my partners for making the show possible. My leading partner, Best in Slot, just released the programmability module for BRC20, making the execution of smart contracts possible for the protocol. I know that's been long awaited by the BRC20 community. Alongside this release, Best in Slot put out what is arguably the most sophisticated DEX for trading Bitcoin native assets called Coin Cooker, which I also highly recommend checking out if you want to dive into the BRC20 trading game and get started executing smart contracts on Bitcoin. I'd also like to thank Cetrea, building one of the leading implementations of a BitVM style bridge for Bitcoin. Cetrea is building what I think could become the canonical Bitcoin rollup, enabling programmability, scaling. Really anything is possible with a trust minimized bridge, which is the unique value prop of these BitVM style rollups on Bitcoin. Lastly, I'm thrilled to announce my newest partner, Spark, which is the leading state chains protocol on Bitcoin. State chains builds upon what was made possible by the Lightning Network for payments, but without the liquidity constraints and the UX challenges that often make self-custodial Lightning impractical.
Spark is also led by one of the leading payments infrastructure teams on the planet, including founders from PayPal, Facebook. They're incredibly well positioned to turn Bitcoin into a true institutional standard for payment systems around the world, and I couldn't be more excited to support what they're up to. All right, on that note, let's get back to the show.
What was the most, I think there's been so much technical breakthrough post Taproot, right? So you have SegWit, you have Taproot, and then all of a sudden, a lot of things become possible that weren't possible before the activation of these soft forks. What was the most sort of surprising or interesting tech that you've seen be built as a result or made possible as a result of these soft forks? Like, what were you happily surprised, or not, but maybe happily surprised to see built that you weren't expecting? Love your face right now, by the way.
I don't know if there are any. I mean, I'd say that the big ones that were envisioned were what would become music too.
That's a good one.
I mean, it wasn't,
that was already in the plan, though. That wasn't a surprise.
Absolutely, because without that, the idea of like a single key path that everyone can always use as long as people agree just doesn't really work.
That was the core reason to bring in Schnorr, ultimately.
Yeah, not just Schnorr, but the key path.
Right.
Itself is really only, not only, but a great deal of the justification is the fact that for many complex things you might want to do, you always have the ability to add a everyone agrees path. But for that everyone agrees to be a single key, you need a key aggregation scheme like music. It doesn't need to be music specifically, but for that part of the argument to hold, you need to have something like that. And I guess music ended up taking more time to develop than I would have liked. But sure, it's here now.
And it was intentional. It was not a happy accident. That was very intentional.
And don't need to rush these things, right? I don't think we should be like, oh, it's been this many years and these things aren't used or whatever. Like, takes time.
Nothing else comes to mind, though, as something that legitimately maybe was surprising. Because,
I bet you want me to say BitVM or something like that.
I'll ask you about BitVM. Don't worry.
It's very cool. I mean, I am skeptical about practicality of course of it, but
you're impressed.
Yeah, sure, and but in more in an academic sense of like, wow, I had no idea this would be possible. But really, do you want to do it that way?
I don't even think Robin Linus wants to do it that way. Yeah. He said as much when I had him on the show. But yeah, but that would be an example maybe of something that surprised you that was made possible by Taproot.
But it's not. I mean, it just due to the fact the scripts are bigger, basically.
Right. It's not really made possible; it just leverages. Yeah. Okay, so that's a good example. Do you think? I mean, that sort of brings me to like a broader question about. Again, I don't think that Robin Linus even wants to use BitVM. He, on my show, literally called it, I think, a clunky workaround to something that should be enabled by soft fork. I think that's the direct quote. Okay. Are you bullish on, these sort of non-soft fork workaround, like all these scaling technologies? No.
Like, I think these things are really only going to be practically useful if they're efficient enough to compete. And so I think the Bitcoin ecosystem should decide whether they want them, and if they do, make it easy.
Yep.
Or choose that they don't want them and then don't do them. I think that this is where my skepticism around wow, what an amazing hack that we can do this thing. It requires a gigabyte
Rube
of transactions
Goldberg machine.
and now we can prove like, okay, I didn't expect that to be possible, but yeah, I don't think that's how things should be done.
I mean, should aside, do you think it even could be done? Do you think it's even likely to be done? Or do you think it really is?
What do you mean by
well, that we're going to solve all our scaling problems through some sort of non-softfork mechanism, right? Through some sort of workaround. You think that's unlikely?
I don't think a soft fork will do it either, but...
Oh, interesting. You think a soft fork would be difficult. Why is that? Everyone says soft fork's all we need.
I mean, what can you do with a soft fork? You can move things to an extension block. That's just hacking around a capacity problem. Like if the ecosystem wants more capacity, you should do more capacity and not...
What about something like trustless bridging?
That's not a scalability solution. That's
You don't
a
think so?
trade-off. Now you have a trade-off where you have the ability to use a different system instead and make them interact. But the different system, like, if you want everyone to use the different system, you've not gained any scalability.
But there may be folks who are comfortable with that trade-off if it can be trustlessly executed, if the bridge can be trustlessly executed, or would you say that's not likely? Or would you say most people wouldn't want that?
You need to be specific here about what the other technology is you're bridging with, because if it is another blockchain, then it comes with its own trust assumptions on proof of work and hash rate and non-reversibility and whatever. And that may very well be a very reasonable trade-off for some people to make, but you can't call that like
It's not trustless.
I don't think that's the right word. It's just it comes with its own trade-offs, so you can't call this like this is in all directions an improvement. It's just making some things better and making some things worse, and you can do that. But I think that it's very hard to call anything like that like a silver bullet.
The best case scenario, basically, even if we did have a trustless bridge, would be you're inheriting the security assumptions of the second layer. Is that sort of that's the trade-off?
Yeah, at best.
At best. That is the best case scenario, which you would say is not akin to scaling Bitcoin. Those are not comparable statements, basically, is the argument.
Yeah.
Okay. Fair.
It's building on top of it. Which is a good thing.
Mm-hmm.
I don't want to
So when you say Bitcoin, the Bitcoin community needs to decide if they quote unquote want this or not, and then, make it easy for themselves or not. Are you not referring to like potentially like a covenants enabling opcode or something like that? Or no?
I have no idea.
No. Okay. You plead the fifth. All right. Interesting. Okay. So I understand it's your policy not to comment on existing proposals, but I'm curious to ask you this question, and if that's also, feel free to plead the fifth on this as well. Are there any proposals that don't exist that you would be interested to see put forth?
So I'll just comment on this. I don't want to be involved anymore in future consensus changes to Bitcoin, period.
Makes sense.
If there is, a big push for a particular change and there's code, I'll review it and whatever. But I just don't want to be the person anymore that pushes or I feel I've just had more than my fair share of influence there.
I think that's fair.
So, no comment.
Do you have a comment, and this will probably be my last question, do you have a comment on kind of what you see as the biggest challenges that Bitcoin faces in the future?
That's a good question. I mean, there are many, right? There's dwindling subsidy, I think, is a big one in like medium long term. I think very few. I don't think we know what the game theory will say there. Like, is it gonna be the case that fees will take over? Where are the fees gonna come from? What fees are people willing to pay to maintain it? Because ultimately that sets in a post-subsidy world sets the security of the system is directly proportional to the fees that people want to pay, and this becomes a tragedy of the commons and all that. So I don't know. I don't want to sound pessimistic here. I don't know what will happen there. Maybe shorter term, I'm worried about centralization aspects making it harder for new miners to compete. And this is already a hard problem, right? Miners benefit, and by miners, I should say, I don't mean pools necessarily, but like big, mining farms, hardware, have scale advantages that, many small hashers don't have. So it is already because of that, plus the combination with access to cheap electricity, access to cooling air, access to, I guess those are the main ones, make it so that there are significant incentives for
centralization
in mining. But on top of that, because these things have existed basically since industrial GPU times in 2013, 2014, maybe. And yet since that time, we haven't really seen miners and mining pools become entrenched. Like, sure, they change slowly, but we've seen them change over time. There are many pools and operators from that era that just are out of business. There are many now that are much more recent. I believe your employer is one of them. So the fact that but I worry this getting worse due to worries like depending on what people do on chain, and it's very much a function of that. But we've seen
or not doing on chain.
We've seen in Ethereum land and other more advanced, like these on chain marketplaces that I don't know. I describe them as front running as a service, but somehow people want to pay money for them, and they're an enormous centralizing force because
MEV basically is what you're referencing.
Yes. But I think MEV is fairly. Another one is the like ordinals, runes craze where people want to get a transaction on a particular spot early.
Yeah, that's why the front running is happening.
Right. They're very different types of front running, but the effect is the same, and it results in the block space becoming a more complex market, and the complexity of the market is a centralizing force. Like I think things are fairly okay in Bitcoin in that regard still most of the time, but
functionally speaking, miners like Mara or miners with, substantial hash are able to kind of take advantage of these things a little bit more easily than others, which sort of accrues more value to them over time.
Oh, particularly I'm worried about the emergence of third-party mempools, basically, where there's a single company or a single entity or conglomerate that instead of broadcasting transactions publicly, everyone just sends their transactions there, and they have business deals with all the big miners, but not with the small ones, because why ideally the possibility remains that you can start, if you don't, put it this way, what's the primary reason why miners at large basically accept every transaction, and there is, as far as I know, in Bitcoin practically no censorship in transactions? I think the reason is because everybody knows that if somehow all miners were to agree that this particular subset of sufficiently valuable transactions they are going to not include, some anonymous miner is going to pop up and mine them for them. And that ability to become a new, ideally anonymous miner, just the possibility of that occurring is an equalizing force that prevents censorship and the properties we want. And I think more complicated marketplaces, like the appearance of mempool.info's accelerator or these direct to miner submission scheme. Yep, Slipstream, exactly. On itself, they're not worrisome, but the trend of, if these things become a substantial portion of income to miners, you basically rule out this ability for an anonymous party.
You edge out solo miners, essentially.
Yeah.
Which I mean, arguably is also already happening just as mining becomes more competitive.
It's true, and I admit that force exists already, so it is already a hard sell, but this on top of that is
extra.
And
I'll do a little shout out to Matt Corallo in this. He's done some interesting work around this. I had him on the show to talk about this specifically. We did an entire episode on this, so I will link that also if folks want to dive deeper down this particular rabbit hole.
So you asked about challenges. Just...
Are those the main ones?
Yeah.
Security budget, minor centralization /MEV as a subset of that.
In terms of technical ones. And then there are, of course, many social ones of how will Bitcoin and its users evolve and agree on things, which I don't have answers for.
Those are sort of more broad governance challenges. Are you concerned about custody? Are you concerned, not to kind of harp back to the scaling conversation, but are you concerned about sort of the paper Bitcoinification, the BlackRocks of the world owning all the Bitcoin and everyone living in a custodied Bitcoin land?
Yeah.
Okay, so that one's also on the table.
I think unlike, I feel that there are many people in the ecosystem who call that out as not real Bitcoin, and I think that's unfair, in the sense that they're holders of currency. They may have outsourced their control, but doesn't change the fact that they're Bitcoin users and in aggregate could have influence, or because they've all given it up too. And that's really the risk there, where one or a few big custodians have such a large percentage of the currency that they form a systemic risk or start having political influence I think that is the risk there. I think isn't so much killing Bitcoin, but turning it into something lacking interesting properties. And
like missing the point, basically.
And I think that that's something we all should keep in mind. Like, value is one, exchange rate is one property, and it's a necessary one for it to function, as a unit of account and a means of paying people. It needs to have value, but at the same time, there are properties that set Bitcoin apart from others, and it's better not to lose track of those.
I think that's such a kind of perfect place to wind down, but I have to ask you one more thing that I forgot to ask you in the interview. Robin Linus specifically requested, he said that you must ask Pieter about Miniscript.
Okay.
And so let's just do like a tiny little segment on Miniscript, because I hear you're a script wizard and you love script, and you obviously.
Am I?
I realized. Well, I didn't know
I've
when I was
written any interesting scripts for Bitcoin.
Well, you wrote an entire scripting language for Bitcoin, which I think, and also I didn't realize until this conversation just now that you actually went to school for scripting languages. Like that was your focus in university.
Programming languages.
Yeah. So you were destined to create your own scripting language. How did the idea for what is Miniscript, and how did the idea for Miniscript come up for you?
So this came out of conversations at Blockstream with Andrew Polstra and Sanket Kanjalkar, who was interning with us at the time. I think it predated him, but he worked on it a lot, where we observed that Bitcoin script is fairly low level and hard to reason about, and we really wanted an ability to write a generic signer. And what I mean by that is often when you design some new thing on top of Bitcoin that uses a particular script, you will design a custom script for it, and you'll write custom signing logic for it. And you are a company doing some kind of 2 of 3 multi-sig setup. They write their own software, design their own scripts, and you can afford to put multiple engineer days into designing the right script for the thing you want to do, and then design the software. But this is really annoying if you want to be more flexible. And so what we wanted is there had been projects that predated Miniscript that sort of were a higher language that could compile to script. There was Ivy by Dan Robinson a couple years earlier, where you have like a fairly nice higher level language where you can describe the conditions with like variables and say, oh, these are the properties I want, and it will generate a script for you. But it lacks the ability to then sign for it.
Pretty key. I said that's pretty key. Pretty
like critical. You'd still need custom logic to okay, now I have such a script, how do I spend it? So what we observed is that we could define a subset of Bitcoin scripts that would be easier to analyze, just at some restrictions, like you can't arbitrarily combine these things. In fact, we just give you a couple building blocks that you can nest within each other and compose, and there's a one-to-one mapping between these building blocks and scripts. So if you I'd say that is what I call Miniscript, or the subset of script that corresponds to it. But with that, we have software that you can just give the script and it would parse it as Miniscript, and you'd see the structure and the meaning come out of it. And then we have a generic signer for that. So as long as you restrict yourself to this subset of script and you have the necessary private keys and pre-images and whatever, you can just say sign and it will spend it for you.
So the core idea here is basically making a version of script that's substantially easier to use and sort of kind of
easier to reason about.
And helps you kind of execute common functions a little bit more easily, specifically. What's the user adoption been like of Miniscript? Who's using Miniscript?
I don't know.
Really? I was going to say, is it difficult?
I haven't really paid attention to it for a while.
I'm curious if Miniscript, was part of the goal.
I think
I assume the goal was to make it easier for lots of people who maybe just were...
Yeah, I've certainly heard of projects that use it under the hood. But yeah, I know they exist,
right?
But
I feel like there should be like Miniscript education. I wonder if there would be, it seems to me like a tool that could substantially increase, adoption of like you said, getting in under the hood with Bitcoin, right? It makes Bitcoin easier to use at that fundamental level. So I'm curious how that's going. That's my big question about Miniscript. I guess we'll see. I'll do some more research. I'll poll some people. I'll let you know. I'll come back to you on that.
All right.
Well, thank you so much, Pieter. This was really, this was such a treat. Thank you so much for being here.
You're welcome.
Hope to see you again soon. And thank you so much again. And this was awesome.